Lake Whatcom, prior to European settlement, was an important location for the native peoples of the region for food and subsistence. Once English settlement began, obviously there was a large resource around Lake Whatcom, being the timber that was present there. And so a number of logging mills were constructed around the lake in the mid to late 1800s and operated through essentially the logging of the whole watershed. As the logging industry kind of started to slow with the resources being depleted, the logging industry then looked at how it might recover some of this money, and so it started selling off properties around the lake watershed to individual private landholders. And that's where we see today is a number of private properties that are predominantly located within the watershed. The challenge with the impacts from especially phosphorus entering the lake and to a certain extent nitrogen as well, they both serve as essentially fertilizers, if you will, and so they can encourage algal blooms and growth of algae within the water. And what happens then is when you have this bloom of algae, as it dies off and sinks down into the lake, it's essentially eaten by naturally occurring bacteria that live in the lake. You'll see a big bloom of then these algae that take a lot of oxygen to metabolize and digest the algae. And so what happens is it depletes the oxygen, which then can impact the ability for fish to survive, impacts the overall, just dynamics of how the lake works. From a water source perspective, it serves as the source of water for the entire city of Bellingham, as well as the Lake Whatcom Water and Sewer District's customers.
The City of Bellingham, they treat the most water and distribute the most in their system, and their intake is in one of those shallower basins. Lake Whatcom Water and Sewer District is the second largest conveyor of water. It is a drinking water source for over 100,000 people.
So from the Lake Whatcom Water and Sewer District perspective, so we operate a water utility that comprises the Sudden Valley and Geneva communities on the South Shore. That water is drawn from Basin 3. If you're familiar with Sudden Valley, it's near the AM and PM beach parks in Sudden Valley. And so we draw from Basin 3 to a treatment plant located there next to the AM beach, where we treat the water and then distribute it to customers throughout Sudden Valley and Geneva. Back to the mid-'80s, based on some of the concerns with degradation of water quality, the City of Bellingham, in collaboration with Western Washington University's Institute for Watershed Studies, began actually conducting monitoring of the lake's water quality, and they've continued that process over the last 35 plus years. In 1992, Whatcom County, the City of Bellingham, and the Lake Whatcom Water and Sewer District all joining forces through an interlocal agreement to create the Lake Whatcom Management Program, to begin looking at how the three agencies could collaborate on protection of the lake.
This whole cooperation started, I think, in 1992 with the three jurisdictions getting together when they recognized the water quality declining. And it's really grown to, we're really very integrated, and we've learned a lot, and we're really focused on implementation. So we've done a lot of the hard work already, so now we're just trying to implement that.
That said, development, it can be challenging and within a watershed, and its impacts on a water body. And so over those last 30 plus years, the three agencies have been working together on ways that we can all work on improving the water quality of the lake, be it stormwater treatment, be it land use regulations, be it land preservation through acquiring lands that haven't been developed yet and setting them aside into perpetuity as open space versus allowing development to occur on those lands.
The city has a property acquisition program, so water customers pay a surcharge on their water bill every month. For most property owners, it's about $17. And that goes into a fund that brings in about $6 to $7 million a year. And then we buy properties in the Lake Whatcom watershed so that we're removing development units and preventing increased development in the watershed. Since the program inception, we've spent about $40 million, and we've purchased about 2,700 acres.
The phosphorus is a surrogate for dissolved oxygen, so we're trying to recover the dissolved oxygen that would normally be in the lake. So instead of rain infiltrating through natural vegetation and natural soil that filters out a lot of the contaminants, when you have driveways and roads and roofs, that water can pick up phosphorus along the way, and then it just routes it straight to the lake. The current calculations say if we took all the developed area and retrofitted that developed area so that 87% of it would act like a natural forest, that would get us back to equilibrium with the lake. So that's a pretty high percentage, and the Department of Ecology has given us 50 years to get there, partially because it's just a lot of infrastructure to install, but also right now we might not have all of the technologies that are needed to get us there. Phosphorus comes in on the sediment, and so a lot of that has come from developed areas, runoff from impervious surfaces, from driveways, roads, roofs. You know, that's a large load of the phosphorus.
The dissolved oxygen component does overlap with drinking water quality, but it's really rooted in supporting the fish biology and their habitat. And so when dissolved oxygen gets too low, they can no longer survive. It was really unregulated logging that caused a lot of phosphorus export. And so what that really means is that only 2% of the watershed should function as developed, and the rest should be a natural forested condition. There are several, like over 200 birds and other animals and vertebrates that inhabit the watershed as a whole.
Aquatic invasive species, primarily, there's plants such as milfoil and things like that, and then there's also animals, primarily in the form of quagga and zebra mussels, which those, if they get introduced to a water environment, can take off and clog water intakes, which can be very costly. If they clog the line from the City of Bellingham's intake all the way to their water treatment plant, that could be extremely costly to try to remove those. And so the city is taking the lead, and with the county and the district financially contributing to it, to try to regulate boats entering the water of Lake Whatcom and Lake Samish, so that we're ensuring that, especially those boats that are coming from distant places that may have been in impacted waters, that they aren't bringing some sort of invasive species to the lake.
And we work closely with the Institute for Watershed Studies to monitor our progress towards removing phosphorus. It took us over 100 years to get in this situation, from all the development and runoff from the development going into the lake and adding phosphorus. So it's going to take us 100 years to get out of this situation. So our contract with IWS, it shows the rate of decline is slowing, which we take as a positive sign. So it's a little bit like turning the Titanic. We're going to be doing a lot before we actually see a response.
I would say it's quite a success story in terms of local cooperation between the three jurisdictions, and you could count the Department of Ecology as a fourth jurisdiction. So I think it's really a great program. Could be a model for other places.